Hello everyone, in this video we are going to learn about the first two geological provinces in New Jersey, which are Highlands and Valley and Ridge. Alright, so these are the two things that we're going to be talking about. Um, for the Highlands in New Jersey, the first one, you have to know that Highlands consists of one of the oldest rocks in New Jersey. And it consists mostly of igneous rocks and metamorphic rocks. So, as I mentioned, it consists of the oldest rocks in New Jersey, and the age of these rocks ranges from 1.3 billion to 750 million years old. Okay, it's very old, and these rocks are actually parts of the basement of the rocks that we have in New Jersey. So you can also say that it actually represents the roots of the Appalachian Mountains. Okay, it is heavily deformed. The rocks here in Highland are heavily deformed, and you can see the patterns later on, and it forms a very good or very nice scenic and rugged terrain in New Jersey. All right, as I mentioned before, it consists of mostly igneous and metamorphic rocks. So this is the example for igneous rocks. It is very widespread, especially granite. Remember, granite is an intrusive rocks that we have, one of the intrusive rocks that we learned earlier this semester. And it occupies about 50% of the highlands. So it covers, a large amount of the highlands. And it has rocks that are one or 1.1 billion years old. Okay, so here's an example of a pink granite that we have here in Patterson that they use as the tile in one of the churches there. All right. So another one, the second one is the metamorphic rocks, such as gneiss that have about 45% of highlands, and quartzite and marble are also there. All right, quartzite and marble are non-foliated metamorphic rocks that make up about 5% of the highlands. Okay, and here's another example. This is a nice sample of gneiss. This is also 1.2 billion years old of gneiss, and here we also have marble that has the same age. All right. Why do we call these rocks as the Highlands? Now, the reason for that is because Highlands of New Jersey consists of rocks that are very resistant to weathering. Okay, and they are more resistant to weathering than the rocks that are making up the Piedmont province here in the eastern part of Highland province, as well as the rocks that make up Valley and Ridge province adjacent to Highland province. So that is the reason why the Highlands stands pretty high. Look at this, much higher than the rocks here on the east in Piedmont, as well as the rocks in the west in Valley and Ridge. So it's all about how resistant these rocks are to weathering. Um, and as I mentioned before, the rocks here in the highlands are very deformed, are highly deformed. And as you can see here from this pattern right here, right? I think we all can agree that this pattern that we have in highlands here shows much more complicated pattern compared to the rocks here in Valley and Ridge as well as the Piedmont, right? So I think we all can agree with that. And that again simply indicates that the rocks in highlands are very deformed, are highly deformed. The rocks in highlands of New Jersey form because of the assembly of the Rodinia, as I mentioned in the previous video. And eventually Rodinia will break apart at about 700 million years ago. Okay, and that actually set up the stage for a new ocean to form, which is called Proto-Atlantic right here. All right, so and it forms a Paleozoic passive margin. okay, that allows the a thick pile of sediments along this margin. So where exactly we are, we're probably somewhere over there, okay. So this is what's left behind from Rodinia after it broke apart, and then look at that. We have some two different microcontinents in between Rodinia and Gondwana right here in the south. Okay, so most of the stuff or most of the rocks in the highlands are mostly because of the assembly of Rodinia, and then remember after that we have the Rodinia got rifted apart, and again it allows the accumulation of rocks that we have in Valley and Ridge Province. Okay, so Valley and Ridge Province. So let's take a look at the physiography of this province, and then let's take a look at the story of the rocks and what is the implication of the tectonic implication of the rocks. Okay, so oops. All right. So Valiant Ridge, it is located in the northwestern corner of New Jersey, right over there. Okay, so you have one ridge right here. There's a nice, well-defined ridge right there. There's another ridge right there, and in between them we have some broad valleys. Okay, and that is the reason why we call them valley and ridge provinces. Okay, it consists mostly of folded and faulted Paleozoic sedimentary rocks that have this age right here, 540 to 370 million years ago, or it goes from Cambrian all the way to Devonian in the geological timescale right here. And the rocks that we have here in this region, it actually recorded the story of the building of the Appalachian Mountains. Okay, and again, it creates such a nice pattern. And this is what we have here in the south, in Pennsylvania. Valley and Ridge can create some very stunning, you know, landscape actually. All right, so these pattern right here, this is what we call as the Valley and Ridge. And this is how it looks like in up in New York. Okay, so these provinces um, show alternating belts of erosion resistant sandstone versus easily eroded shale and limestone, and that is the reason why it creates such a nice valley and ridge pattern like that. All right, so the rocks tell us a story, and most of the rocks in the Valley and Ridge tells us a story about the building of the Appalachian Mountains, as well as the assembly, as well as the beginning of the assembly of Pangaea. Okay, and as I mentioned earlier, I think from the previous video that we always like to start from the bottom to top, right? So these are the stratigraphic section that we have in Valley and Ridge. This is a very simplified stratigraphic section right there. We start from the bottom, we got some clastic sediments, and then we got carbonate sediments, and these two types of sediments, they represents the passive margin, the formation of passive margin after the Rodinia just broke apart. And then after that, we also see some records of deep basins by these clastic sediments in the middle. And then after that, we have some coarser sediments coming in on top of that, and capped by another set of carbonate rocks at the top. Okay, meaning that we have shallow basin right here, deeper basin, and then shallow basin again. Okay, so how does that happen? So basically, the very first thing here is the clastic sediments, which is represented by the Hardiston's sandstone that eventually got metamorphosed and became quartzite. But this is how it looks like. So that is the very first pile of sediments in the Paleozoic passive margin. And then on top of that, we have some carbonate rocks. Okay, carbonate rocks, because we know that these rocks consist of shallow marine organisms that live in a carbonate environment, such as these algae features right here, or some reef that develop within the rocks that indicates that we have shallow water carbonates. And then this is the illustration of the shallow water carbonate right here that form in the passive margin in the Paleozoic, which indicates that the ocean was pretty warm at the time, and it actually mostly it was free from the source of quartz and clay that are coming from the land. Okay. Um, the next one after carbonates, we see the deepening of the basin that allow the deposition of fine-grained clastic sediments such as shale. Okay, well, occasionally we have sandstone beds right here, but most of the strata or rocks that make up this section right here were deposited in a deeper basin. Okay, and then the next one, I'm gonna show you how it looks like. So how the deposition on a model of these rocks look like. So here we got the first clastic sediments. On top of that, we get the carbonate. And then now we have the source from the east. They're coming here, dumping sediments into our passive margin ocean right here, which indicates that the ocean in the middle, the ocean of the Paleozoic passive margin, was about to close. Okay, and that is the reason why we have some delivery of sediments from the east. And again, it was overlying by the Shoangan Formation, coarse facies of sedimentary rocks here. And here are some of the rocks that you can see in the Delaware Water Gap. So all of these rocks right here, they're all part of the Shoangan Formation, which is the coarse sediments that indicate the shallowing basin after the formation of the deep basin. All right. And then last but not least, the stratigraphic section is capped by another set of limestone rocks or carbonate rocks that indicates that we are in a shallow water carbonate again. Okay, so the environment, the depositional environment has changed dramatically within the valley and ridge provinces. And because we have the shallowing ocean, that again, another clue for us that, you know, the ocean right here in the middle is indeed closing, right? Because if it's closing, that, you know, the water column will get shallow and shallow, and then after that, that again, that indicates the process of the assembly of Pangea that will create the supercontinent Pangea that we already talked about at the beginning of this course. Okay, and that would set the stage for the subsequent rocks that we have both in Piedmont as well as in coastal plain that we're going to talk about in the next video. All right, so I'll see you over there. Bye bye now.